Example 3. Consider a standard 52 card deck of playing cards. I draw one card and look at it. I tell you the card is red. What is the probability it is a heart? So we have a conditional probability here. We define it as the probability of B given A equals the probability of A and B divided by the probability of A. So here we have the probability of a heart, given you have a red card already, will equal the probability of a red card and a heart over the probability that you have a red card. This will equal 13 over 52, the probability of a red and heart card, divided by 26 over 52, the probability of drawing a red card, which equals 1/2, or 0.5. So the probability a randomly drawn card is a heart, given it is red, is 0.5. Okay, now I draw one card and look at it. I tell you the card is a heart. What is the probability it is red? Again, this is conditional probability. So we have the probability of red given a heart, which will equal the probability of red and a heart over the probability of just a heart. In this case, we have 13 over 52, the probability of getting a red card and a heart, divided by the probability of a heart, which is 13 over 52. This simply equals 1, so it will always happen. The probability a card that is a heart is red is 1. Are red card and spade independent? Well, no, they're not. A card that is red is automatically not a spade. So they can't be independent. As soon as you draw a red card, the probability of getting a spade changes, which means they can't be independent. Are red card and spade disjoint? Yes, they are. A red card and a spade share no common outcomes. You cannot draw a red card that is also a spade, so they must be disjoint. Okay, are red card and ace independent? So now let's look at some probabilities here. The probability of an ace equals 4 over 52, which is 1 over 13. The probability that you get an ace given the card is red will be 2 over 52 divided by 26 over 52. This simplifies to be 1 over 13. By definition, if the probability of ace and the probability of ace given it's red are the same, then they're independent. So that's what we have here. Probability of an ace equals the probability of an ace given the card is red. So red card and ace are independent because the probability of an ace equals the conditional probability of an ace. Are red card and ace disjoint? Red card and ace are not disjoint because they share outcomes. You can get a card that is both red and an ace. Are face card and king independent? So again, let's look at the probabilities. Let's find the probability of a king and the conditional probability. So probability of king is 4 over 52, which equals 1 over 13. The probability of a king, given you have a face card already, will be the probability of a king and face card, which is 4 over 52, divided by the probability of a face card, 12 over 52. This equals 1 over 13 over 3 over 13, which is 1 over 3. So drawing a face card and a king are not independent because the probability of drawing a king is not the same as the probability of drawing a king given you have a face card. Are face card and king disjoint? Again, they're not disjoint because they have common outcomes. So face card and king are not disjoint because they share outcomes. You can draw a card that is a face card and also a king.